Welcome to SRA 221. In this lecture, we will be talking about buffer overflow attacks. In computer security, buffer overflow is an anomaly where a program, while guiding data through a buffer, overruns the buffer boundary and overrides the adjacent memory. With this simple definition, you have now been introduced to the most common form of security vulnerability of the past 2 decades. Buffer overflow is a software vulnerability that is extensively used for deploying attacks. The goal of an attacker who exploits buffer overflow is to subvert the function of a privileged program. Essentially, the attacker is taking control of a program by leveraging or exploiting the buffer overflow vulnerability. So you may be wondering, what is a buffer? A buffer is an array or string where the data is held. It resides in memory and is usually of predefined size. All programming data elements, programs, and variables are stored in memory during execution. There are spaces with operating system, and the memory is typically structured as an array and are active and open until the program is used. Buffer overflow is, by definition, an anomalous condition where a process attempts to store data beyond the boundaries of a fixed length buffer. The result is that the extra data overrides to adjacent memory locations. This data that has overflown may write on other variables, other program flow data, etc. A typical attack scenario involving buffer overflow is as follows. Suppose a user enters data into a web form. Once the web form is submitted by the user, the data is sent to the server. Suppose that the web form has information such as login and password information. What the server does is essentially writes the user's data into a buffer, which is a fixed length of memory space. However, also assume that the server does not check the length of the input data. Therefore, the data that the user entered may overflow the size of the buffer allowed. Sometimes the spill of data from this buffer can enable an attacker to do unauthorized actions. Here we will go over an example of buffer overflow. Suppose I have a simple buffer variable length of 10. If I want to attempt an attack, what I can try to do is write in position 20 of this buffer, number 37. So what happens when this is executed? Depending on what resides in the memory of location buffer 20, the attacker may be able to override the user data, code, or even system data. Let's take a look at another example. Consider the case of a variable used for our user authentication. This is a Boolean variable, assuming that if the password is verified, then the Boolean value's memory is set to true. Otherwise, it will be set to false. If the password is verified and the variable is set to true, then the authentication is successful. The attacker can try to write on the variable buffer and override it until it reaches the slot allocated for the Boolean flag and sets it to T. In general, the buffer can overflow by affecting user data, user programming code, system data, and system code. This is all dependent on what the attacker target is and how the memory is structured at the time of the attack. A final example here is suppose that you have a program that has defined 2 data items, which are adjacent and memory. Let them be variable A and B. Variable A is an 8-byte long string buffer. Variable B is a 2-byte long string buffer. The characters here are 1 byte wide. The program attempts to store the character string excessive, as you can see here. As you can see, character E has overflown to variable B, and therefore it has caused a buffer overflow attack. Now that character E is misplaced, it is occupying the space allocated for variable B.